board so you guys could like have a little template. That's really always a good thing to do, like the first time you work a problem, right? I mean, you certainly don't want to have to rely on it as a crutch, but the first time you work a problem, it's always good to have a small little template available. I'm going to erase all these AUs because we probably are not going to be using gold. We probably will be using water though. And erase everything else. All right. Okay, so here's what we got. We have ourselves 500 grams of iron. All right. So that's the mass of iron. We're going to need a specific heat of iron, final temperature of iron, an initial temperature of iron. This metal has changed to iron. So basically the only difference will be instead of using gold, we're using iron, and which of course will change the specific heat. The masses will change and all of that. That is 212 degrees initially. It's placed in 2 liters of water, so let's put that down there, 2 liters of water. And that is at 24 degrees centigrade. That's going to be my initial temperature of water. And that's pretty much all we know. But let's not get too much in a panic, right? Because we've got a table. So what is the specific heat of iron? 0.473 joules per gram degree centigrade. All right, so again, don't have to give birth to the number. It's in a table. Now, the reason it wasn't given there is, you know, this expects you to go back and forth in your chapter. Final temperature, iron, don't know. Mass of the water, don't know. Because the volume of the water is 2 liters, right? Okay, specific heat of water is 4.184 joules per gram degree centigrade. So what is the mass of water? Well, let's go off on a little tangent here. Okay, so this is just some little aside to get that. Here's what we know. We know that density equals mass divided by volume, right? Now, if we rearrange this equation, I know that the mass of water equals volume times density. Okay, well, what is the density of water? 1 gram per milliliter in this classroom here, all right? Well, this is 2 liters, so can we just put a 2 liters there and that'll cancel out? No. What's that going to be? 2,000 milliliters. So what is the mass of water? Well, 2,000 times 1 times gram is 2,000 grams. Right? So from chapter 2, we did these density considerations here. Okay? The only thing we don't have is the final temperature of the iron and the final temperature of the water. Okay, so this is iron. Okay, 2 separate equations. We're putting the metal into the water, assuming no heat loss to the surroundings and all of that. Okay, so the heat that leaves the metal, which in this particular case is iron, is transferred in the form of heat to water. How am I doing so far? Good. Wonderful. If this was the test, how would you have done on it? If it was an open book test, would you have done okay, right? Of course, now don't misconstrue that. Your test will not be open book. But now if I give it to you today, it would have been right, because who's had time to study anything? All right, so what is the mass of iron here? Suppressing the units again is 500 grams, 0.473. X minus 212. Again, we're going to use the same argument that at thermal equilibrium, the final temperature of the iron and the water will be the same after so many seconds of stirring it around a bit. The mass of the water is 2,000 grams, right? We've been through that diatribe at 4.184. Final temperature of the water, we don't know, and the initial temperature is 24 degrees centigrade. Doing the algebra, we're going to get 500 times 0.473 All right, so that's going to be negative 236.5x plus 50,138 equals 8368x minus 200,832. So now what have I done, just to recap? I've taken negative 1 times 500 times 0.473 and then distributed that to find that number. Then distribute it to get that number. Negative times a negative is a positive. All right. Then I've taken 2,000 times 4.184 and distributed it to get the x, and then I've distributed it to get that number, right? Positive times a negative is a negative. Now John's done said, why don't we combine these like terms? All right, so let's do that. Plus 236.5x plus 236.5x. So 8,368 plus 236.5 equals, okay, so this number here is 8604.5x. We're going to add that over here, so that's going to be a positive 200,875. Wait a minute, 200,832 plus 50,138. 250,970. All right, what do you want to do now? Divide by what? 8604. All right, and divide by 8604.5. Not x. Okay. So what does that mean? 250,970 divided by 8604.5. 29.2 degrees centigrade. How are we doing? Good? Okay. Let's take a look at this. Now, what is x? Remember, x means nothing in chemistry, only in math. X is the final temperature of the water, which is 29.2 degrees centigrade. It's also the final temperature of the iron. It's also the final temperature of the mixture. But get the nose back in the book. Here's what it says. It says, what is the change in temperature of the water? It didn't say what the final temperature of the water was. It says, what's the change in temperature of the water? Final temperature of the water minus initial temperature of the water. Final temperature of the water, 29.2. Initial temperature, 22. So what's 29.2 minus 22? Is it 5.2? I'm getting tired. 29.2 minus 22? Something ain't right. 24. I don't know where I got 22 from. 24. That'll do it. All right. Been a long day since 8 o'clock. Every summer I do this to myself. I don't know why. Okay, so 5.2 degrees centigrade is the final Holy Grail answer, right? On a test, this problem will be 15 points, almost guaranteed, and you will get partial credit depending on how far you move throughout the problem. What are common mistakes? 1, you forget to do this brown right here, and you stop at 29.2. If you forgot to do something like that, you're probably going to get 12 out of 15 points, or maybe 13 out of 15 points, right? The next common mistake is you're going to forget, and what number will go here? A 2. Because you're given 2 liters, right? Now, do you think that's going to change your answer or not? Yeah, it's going to be tremendous, right? A tremendous change in your answer. So, if you forget to do something like that, that's a deduction